For any Linux user, it's circular to be knowledgeable in the use of the log files here. So log files store information about events that occur when the operating system and applications are run. So including any errors and security alerts, of course. So your system will log information automatically based on the series of rules that I will show you how to configure in this lectures. So I think this lecture will, this section of our Udemy course will be 2 lectures actually. So as a hacker, the log files can be trailed to your target activities and identity. So, but it can also be a trail to your own activities on someone else's system. So a hacker therefore needs to know what information they can gather, as well as what can be gathered about their own actions and methods in order to hide that evidence here. So on the other side, anyone securing Linux systems needs to know how to manage the logging functions to determine whether a system has been attacked and then decipher what actually happened and who did it. So this lecture shows you how to examine and configure log files, as well as how to remove evidence of your activity and even disable logging altogether. So first we will look at the daemon that does the logging here. So the syslog logging daemon. So Linux uses a daemon called syslogd here. So to automatically log events on your computer. Several variations of syslog, including syslog here, including rsyslog here, and rsyslog actually syslog ng here we have actually. So are used on different distributions of Linux. So and even though they operate very similarly, some minor differences exist, of course. So Science Scala Linux is built on Debian, and Debian comes with rsyslog here by default. We focus on that utility in this lecture here. So if you want to use other distributions, it's worth doing a little research on their logging systems. So let's take a look at rsyslog on our system here. We will search for all files related to rsyslog here. First, open a terminal in Kali and enter here locate rsyslog here. So as you can see, numerous files can contain the keyword rsyslog here. So some of which are more useful than others. The one we want to examine is the configuration file rsyslog-conf here. So the rsyslog configuration file, like nearly every application in Linux, rsyslog is managed and configured by a plain text configuration file located as is generally the case on Linux. So in the etc here directory, in the case of rsyslog here, the configuration file is located at etc rsyslog.conf and open that file with any text editor here, for example mousepad etc rsyslog here.conf here, and as you can see here, we opened this file. So it's read-only, as you can see here. If we want to change, we should use these system files. We was using sudo command for root rights here. So you shall see a text file like that. So as you can see, here the rsyslog.conf configuration file comes well documented with numerous comments explaining its use. So much of this information will not be useful to you at this moment, but if you navigate down below to line here 51 or 49 here, you will find the rules here, as you can see here. So this is where you can set the rules for what your system will automatically log for you. So our syslog logging rules here. The RCS log here rules determine what kind of information is logged. So what programs have their messages logged and where that log is stored. As a hacker, this allows you to find out what is being logged and where those logs are written, so you can delete or obscure them. Scroll a line to 56 here, and you should see something like this here. So each line is a separate logging rule here that says what messages are logged and where they are logged here. The basic format for these rules is, for example, facility priority here and the action here, like that. So the facility keyword references the programs such as mail here, as you can see here, mail, like kernel or LPR, like this here, kernel LPR here. So the priority keyword determines what kind of messages to log for that program. So the action keyword here, as you can see here, action and priority. On the far right here, as you can see here, action keyword here references the location where the log will be sent. Here, as you can see, there is the where our logs will be sent. Let's look at each section more closely, beginning the facility keyword here. As you can see here, there is the facility keywords here, and which refers to whatever software is generating the log, whether that's kernel, the mail system, or the user here. So the following here, as you can see here, is a, for example, out brief here is security authorization messages. For example, a cron here is clock diamonds, and kernel here is kernel messages. Diamond here is other diamonds, which stores, as you can see, var log diamond log here. And LPR is means printing system here. Mail is, as you know, mail user mail system here, and this is the user generic user level here. So you can select more than one facility by listing them separately by comma here. So the priority tells the system what kinds of messages to log here. So for example, codes listed from lowest priority starting at debug to highest priority ending at panic here. So if it's the priority here is like that, messages of all priorities are logged. So when you specify a priority, messages of that priority and higher are logged. For instance, if you specify a priority code alert, the system will log messages classified as alert and a higher priority, but it won't log messages marked as crit or any priority lower than the alerts here. So first I want to show you how priorities here and priority names here. So here is 12 priorities, I think. So the first is debug. Yes, there is a actually 9. Yes, debug here, info, notice here, warning here, warn, error, crit, alert, merge, panic, 11 here. So the codes warn. So there is the most priorities here. For example, debug is the not very priorities, info little, info's priority is bigger than in debug, notice the priority is bigger than info, warning priority is bigger than notice, like that. And the most prioritized this message here, log here, is panic. So for example, there is a warn here, for example, warning, actually not warning, warn, error, and emerge here, and panic here have all been deprecated and should not be used. So if you want to use it, the action is usually a file name and the location where the logs should be sent. So don't save. So we don't want to save. It's just a note here. So note that generally log files are sent to var log directory. So with a file name, of course, that describes the facility that generated them, such as the out here, like that here, out, or kernel mail, like that, as you can see here. This means, for example, that logs generated by the out facility will be sent to var log out.log here. So we can see where our mail logs goes, var log mail.log here. So like that, for example. Actually, let's look our terminal here. So we can clean automatically up logs with log rotate here. So log files takes up space. So if you don't delete them, so actually I forgot mentioning you. So you can change this log files the direction here. For example, if you want to save your mail log to your home directory, you can change it here, but I will not change any of it. So you can also automatically clean up logs with log rotate command. So log files take up space. So if you don't delete them periodically, they will eventually fill your entire hard drive. On the other hand, if you delete your log files too frequently, you won't have logs to investigate at some future point in time. So you can use log rotate to determine the balance between the opposing requirements by rotating your logs. So log rotation is the process of regularly archiving log files by moving them to some other location, so leaving you with a fresh log file. That archived location will get cleaned up after a specified period of time. So your system is already rotating log files using a cron job, so that employs the log rotate utility. So you can configure the log rotate utility to choose the regularity of your log rotation with etc log rotate command here. Let's open it with the text editor, sudo mousepad etc log rotate here conf. As you can see here, we can see our log rotate configuration file. So now let's talk about them. So first is weekly. As you can see, there's a comments here. So weekly, what is weekly? First, you can see that the unit of time you rotate numbers refer to this here. For example, the default here is weekly, meaning any number after the rotate keyword always refer to weeks. So further down, you can see the settings, how often rotate logs here. The default setting is to rotate logs every 4 weeks here. So this default configuration will work for most people, but if you want to keep your logs longer for investigate purposes or shorter to clean them out quicker, this is the setting you should change. So you can change it here. So, for instance, if you check your log files every week and want to save storage space, you could change the setting to rotate 1 here. But I will leave it as it is. So, if you have a plenty of storage for your logs and want to keep a semi-permanent record for forensic analysis later, you could change this setting to rotate, for example, 26 to keep your logs for 6 months, or rotate 52 to keep them for 1 year. Here. So by default, a new empty log file is created when old ones are rotated out here, as you can see, create here. So as the comments in the configuration file advise, you can also choose to compress your rotated log files here, as you can see, compress, but it's commented here, and this means this uncompressed log files here. At the end of the rotation period, the log files are renamed and pushed towards the end of the chain of logs as a new log file is created, replacing the current log file. For instance, var logout will become var logout 1, then var logout 2, and so on. If you rotate logs every 4 weeks and keep 4 set of backups, you will have var logout 4 but no var logout 5, meaning that var logout 4 will be deleted rather than being pushed to var logout 5. So you can see this by using the locate command to find out log files with a wildcard here. For example, let's find it. Locate, as we did earlier, var log here out.log and then comma here. As you can see here, we have two outlog 1 and outlog 2 here. So for more details on the many ways to customize and use the log rotate utility, see the man log rotate file, log rotate page here, as you can see here. So as you know, man is the help documentation for every command in Linux. So we discussed it in previous lectures so far. So this is an excellent resource to learn about the functions you can use and the variables you can change to customize how your logs are handled. So once you become more familiar with Linux, you will get better sense of how often you need to log and what options you prefer. So it's worth revisiting the log rotate.configuration file. Remaining stealthy. Here, actually, I won't look at how many minutes we do. Okay. Remaining stealthy. Once you have compromised a Linux system, it's useful to disable logging and remove any evidence of your intrusion in the log files to reduce the chances of a detection. So there are many ways to do this, and each carries its own risks and level of reliability. So we can remove evidence and others here. So first you will want to remove any logs of your activity. So you can simply open the log files and precisely remove any logs detailing your activity line by line using the file deletion techniques you learned in previous lectures. So which would look, however, here this could be time consuming and leave the time gaps in the log files. Which would look suspicious. Also, deleted files can generally be recorded by a skilled forensics investigator. A better and more secure solution is to shred the log files with other file deletion systems. A skilled investigator is still able to recover the deleted files, but suppose there was a way to delete the file and overwrite it several times, making it much harder to recover. Lucky for us, Linux has built-in command appropriately named shred here for just this purpose. So to understand how the shred commands work, take a quick look at help screen here. shred shred help. So as you can see here, shreds once as file. So on its own, shred will delete the file and overwrite it several times by default. So shred by default shred overwrites 4 times. So generally, the more times the file is overwritten, the harder it is to recover. But keep in mind that each overwrite takes time. So for very large files, shredding may become time consuming. So two useful options to include are the F option, which changes the permissions on the files to allow everything if a permission change is necessary, and in option here, in option which lets you choose how many times overwrite files. As an example, we will shred log files 10 times, using, for example, shred sudo shred f and n 10 times. So var log out log here. So we need the F option to give us a permission to shred out files, and we follow the N option, which is desired number of times to overwrite. So after the path of the file we want to shred, we include the wildcard asterisk. So we are shredding not just the out.log file, we also shredding any log files that have been created with log rotate, such as outlog1, outlog2, outlog, and so on. So now, once you shredded the file, you will see that contents are indeciphered and gibberish here. So mousepad var log here, outlog1 is permissions denied, sudo here. As you can see here, there is nothing to see because it's deleted out. So now the security engineer or forensics investigator examines the log files, and they will find nothing of use because none of it's recoverable. So now we can, lastly, let's disable logging here. Another option for recovering your tracks is to simply disable logging. When a hacker takes control of the system, they could immediately disable logging to prevent the system from keeping track of their activities. This of course requires root privileges. So this to disable all logging, the hacker could simply stop the rcc log daemon, and stopping any service in Linux. Use the same syntax here, service here. I will write syntax here, service name, and start, stop, or restart here. So to stop the logging daemon, you could simply enter here service rcc log stop here, and it is need root privileges here, and enter your root account password, and as you can see here, we stopped syslog here. Now Linux will stop generating any log files until the service is restarted, enabling you to operate without leaving behind any evidence in the log files. So start here. So and here you can start any service like that. Log files track nearly everything that happens on your Linux system. They can be invaluable resource in trying to analyze what has occurred, whether it be malfunction or hack. So for the hacker, log files can be evidence of their activities and identity. So however, an astute hacker can remove and shred these files and disable logging entirely, so just leaving no evidence behind. In Linux terminology, a service is an application that runs in the background waiting for you to use it. So your Linux system has dozens of services pre-installed. Of this, the most well-known is the ubiquitous Apache web server, which is used for creating, managing, and deploying web servers. But there are so many more. For the purpose of this lecture, on services, I have selected just 4 that are of particular importance to the hacker. Apache Web Server, OpenSSH, MySQL, and PostgreSQL. So in this lecture, you will learn how to set up a web server with Apache, physically spy with OpenSSH, and access with the MySQL. So, and store your hacking information with PostgreSQL. So starting, stopping, and restarting services. So before we begin to work with these 4 critical circular services, let's start by examining how to start, stop, and restart services in Linux. Some services can be stopped and start via graphical user interface in Kali Linux, much as you would on an operating system like Windows or Mac. However, some services require use of the command line, which we will look at here. So here is the basic syntax of services here. Service here, service name, start, stop, or restart here. So this is the basic syntax of managing services. To start the Apache 2 server, web server, or HTTP servers, you will enter here service here, Apache 2 start, and enter your password here. To stop the Apache server, write service Apache 2 stop, like that, and enter your command here, password actually. So usually when you make a configuration change to an application or service by altering its plaintext configuration file, you need to restart the servers to capture